Hi, my name is Ken Lasserson. I wrote and run the site Microbiome Prescription. I'm basically a data scientist, mathematician by training, skills, and experience. And what I'm going to do is take a look at something which came across my email, which seems like it's maybe worth exploring. It is literally, at least in my opinion, very much cutting edge in terms of DNA and the microbiome combination. So what we're going to do is look at investigating a SNP, which is a DNA mutation, and a microbiome. We know that the microbiome and the DNA of a person interplays extensively with each other. One evolves with the other, and that means if there's a DNA mutation, the microbiome may reflect the mutation, and it becomes an interesting thing. So let's go on and let's do a quick summary. The purpose is to provide a walkthrough for people dealing with DNA mutation SNPs. It is a continuation of a thought experiment. So it's not being demonstrated by clinical studies, etc. It is a conceptual exploration, a hypothesis, if you wish. Remember, my skill set is not medical. I am basically a data scientist, artificial intelligence, very heavily trained in formal mathematics. Hence, I'm probably uber logical, which can be a problem because I just go through things logically and systematically and work from there without some constraints. I'm also a high functioning ASD, which means that I tend to be, in some ways, extra focus on issues that catches my attention, which has some good aspect and has some bad aspect because I may not see peripheral issues as well. As with all medicines, natural or otherwise, please consult with experts who are experienced before starting this or any other supplement programs. Usual medical disclaimer: I'm not giving medical advice, I'm describing a thought experiment. Okay, what we're going to do is start with KEGG, which is the Kyoto Encyclopedia of Gene and Genomics, which is a community supported by the academic community repository of a massive amount of data about genes and the genome. And what we're going to do is we could look up a mutation, one particular mutation, and then we go to note the enzymes and also the molecules associated with it. Because those things we also are able to read from the microbiome. So what we do is, so this is a DNA mutation, which where, for example, we know that the mutation results in too little of something being produced. Let's see if the microbiome produces the same substance. So that, in theory, if your DNA doesn't produce enough, but your microbiome produces a lot of it, things may normalize. So the concept is along that line. Analogy which can be think of is diabetes. Somebody doesn't have enough insulin produced, they get a insulin projection. If we can find a bacteria that produces insulin, then encouraging that bacteria could help diabetes. So it's the same concept, is that we are looking for a way to get a substitution. The enzymes involved are not particularly easy to make into a capsule or whatever. They tend to be volatile. Many enzymes are very much oxygen sensitive, so they can exist in an oxygen-free environment, and they break down very fast exposed to oxygen, which of course means it's a problem. Plus, if we had as a pill, it has to be able to survive going through the whole digestive system, which is a whole other issue. And what I'm hoping is that my thought experiment will cause somebody to do a formal study to see if indeed the patterns, which I think may be there, actually are there, documented, and convince medical practitioners that this is something that needs to be seriously examined. What we're going to do is the defect, which is called a G6PD. It is associated with the so-called Fragile X syndrome in autism, and we can see a description there of what it does. Basically, it can cause anemia. Red blood cell breaks down faster than they are made, and if they break down faster than they are made, then you're going to have problems with oxygen delivery. Problems with oxygen delivery can mean things like brain fog and a whole bunch of other cognitive neurological issues may arise because the brain doesn't get enough oxygen. So it is a very significant one, and it was the one that got me interested in it. Somebody asked me a question about G6PD, and I said, oh, well, could we? And it looks like we can. So let's take a look at it. So first, make sure you know what you're looking for. Make sure you know which DNA mutations or mutations it is involved. Get some basic information, and then we go on. So I go over to KIG and I do a site search, and I'll get to that in a moment, and I'll find what they say about it. So it is goes through and gives the descriptions. More importantly, at the bottom right, it gives the modular. These are modulars which are involved with this particular thing. Modular, you can think of as a component consisting of many chemical reactions or other things like that. So we can see that we have a bunch of the modulars listed there, which is nice because I have these same modulars available on my site against the microbiome we have. So in other words, hey, from here we can go to the other site and take a look at it. The next thing we do is we look for the enzyme, and usually the process I do is very simple. I do a site search using Google. Site specify KEGJP, give the DNA Snp name, and type the word enzymes, and voila, we end up getting entries, and we see we have one definite match to a particular enzyme. And then also we have down below, we have the another one which we have a matching of letters, but it has an extra H on it. This may or may not be significant. We'll see in a few minutes. Okay, so we now have the module names, and we have some of the enzymes. There may be more enzymes involved, but let's for the moment just keep to these two. And let's go on to actually do it. The process is very simple. You go in and you log in. You probably are going to be using email links, so I'll just go through and log in my demo. And what you have is where everything is hiding is up in the multiple samples comparison. So we have the two of them, and you have a choice of things. And these two, the enzymes and the modulars, are the ones which are interested in. We just basically select whichever we want, select which examples of our microbiome we want, and click review. So we are on the enzyme page, and what we're going to do is we are going to type in the 1.363, which is the items which we have from the cake site, and we'll see what it is. I can see the amount here. Wolf mid-range. This person do not have this particular defect. I wanted to simply show you how to find it easily. And the next one we go along is the 49. And again, we have everything in the middle. Now, at this point of time, we see the count, which is the count of the number of bacteria that produces this enzyme. So if you click that, you will actually go through and we'll see all of the bacteria which are involved, and we have 50 different bacteria which are involved. And so we can do here and take a look down, and you can see if there's any particular one which dominates. And what we find is I think the duplication is it's probably a bug in the page. You need to track that down. But what we have is that the count seems to be large, coming from one or two particular items of bacteria, and we can now proceed with it. And what I should do is actually, oh no, I can't. Okay, so that will give you an idea of which bacteria are the main contributors. So we have particular ones which you can do or identify by the count, and you see relatively high count of these bacteria, but the overall count was reasonable. Now let's go back and do the same thing for the modular. And again, we have a report, and we see the modular number are there. So if we go and take a look back at the reference page, we see that our modulars are M00004. So I'll just type 0004 right there. And you can see the relative amount. As with the other things, if you click on the back on the count, you'll see the breakdown of what actually produces it. And if you go back and we look for the next one, which is 006. And then we have that one, and you can see again the percentile ranking and the A count of the number of bacteria that produce that enzyme. The last one is 08. And we can see it was low here and up here. But taking a look up at the top, is we're dealing with a relatively low count, and probably should not be given that much weight because we really don't have that many matches. And here's where again the problem is that the bacteria that the labs identify is not all the bacteria which produces it. So the result is they could either be misidentifying or just not identifying some of the bacteria you have which contributed. So what we have is we have an estimate over what is identified and known, and we get estimate from that. So if you're curious to see what those are, we can go down and we can see what it is, and we see that we only have 8 things. E. coli is one of them, which indicates that's a good thing. And if we go back and take a look at our earlier example, that was 008, and we have again we have the items there, and we have that earlier example, and the main difference between the two is that there were a growth of E. coli. So that improves the situation. So you can see the relative accounts. Some things went down slightly, some things went up. But the E. coli and related things are the things that went up. Okay. So what we have done is we have gone and taken a look at how we can use the DNA SNPs, which we know are involved. From that, go over to KEGG to identify the modules and enzymes which are involved. Then we can look at the microbiome sample to see how much of the same enzymes are being produced by the bacteria in the sample. And if there is an area of concern, then you know which potential bacteria are of interest to modify. The bacteria which are listed are only those which you have in the sample. There are other bacteria, but if you don't have it being reported, we ignore that. So we basically work from what is there and subset only to the bacteria which you actually have in both of them. And if you have it in one but not the other and you have multiple samples, then that's fine. That's basically it. So I'll shut up and let you go and explore it. Again, this is a thought experiment. It is taking concept, seeing that we can make a connection between a variety of dots here, here, and here. Whether or not the connections are beneficial is a to be determined.